Hey guys, hope you're all doing good. In this video, I'm going to be teaching about arrays. Alright. Now this is a basic video. So if you're already familiar with the concept of arrays, just move on to the next video. Alright. So what I'm going to do is I'm first going to create a variable and I'm going to say that a is equal to 5. Now remember, in Octave and Matlab, everything is a matrix. So when I say a equal to 5, I'm actually creating a matrix which has one row and one column. How do I know I'm right? If you look at the workspace, right, you can see that a is equal to 5 and here the size is 1 comma 1. That means it has one row and one column. Now what I can do is I can say that a is equal to, within square brackets I can type in 5 and that's going to give the same results. The program has already run. Now what I can also do is I can type in a is equal to 5 6, right? So now what's going to happen is the value of a is initially going to be 5 and line number 6 is doing the same. But when line number 7 is executed, the value of a is going to be overwritten. So if I execute this program, you can see that the value of a has now changed. And then what I can do is I can go back and then say that a is now again 5. And then I can say that a is now a string called as an array. A is now a string called as array. If I execute this, you can see that only that last result would be shown. All right. So this is a simple array. Now, why do you need to use arrays? Well, an array is basically used to store a group of numbers that actually mean the same thing. An example is I can create an array called density, which holds the densities of different materials. So the values can be same. It can be 101, 102, 103, whatever. But they all represent density, which is a number at the end of the day. So if I execute this, you can see that I have different values of density. Similarly, what I can do is I can have a two-dimensional array. So for example, I'm going to have an array called student marks, right? So here what I'm going to do is I'm going to type in a two-dimensional matrix. Each row is basically representing the marks that a particular student has scored in a particular subject. So for example, so there might be a student who has got 100 in mathematics, 96 in physics, 78 in English, and maybe 40 in social science, right? And then another student might have received 95 or 90 in mathematics, 56, 34, and maybe 24 in social science. And similarly, what I can do is I can add one more example. I'm just going to make up the numbers. You can type in anything you want. Now if I execute this, you can see that this is the student marks. It's a 2D data. Each row represents a student. So for example, this can be the marks scored by Ramesh, this could be by Suresh, and this could be by Vignesh, right? Doesn't matter. I'm just making up those names. If you're not aware of any Indian names, you can say that this is John, this is Mark, and this is Mike, right? Each column represents a particular subject. All right. So this is what you call as a 2D data set. Why do you need this? Well, if I have an array, I can then extract the data. For example, I said that the first column represents the student's score in mathematics. So what I can do is I can say that student marks of, I want all the rows of the first column, right? And I'll just get 100, 90, 90. All right. Similarly, I can get the second subject marks by changing the column index. And I can get the third subject marks by using index number 3 and get the last subject marks as well. Similarly, say that I want to get the first row. Remember, each row represents the marks obtained by a particular student, right? So if I want, what I can do is I can type in student marks. Oops. This time I want all the columns of the first row. So I know that the row number is 1 and the column number is all the columns. So if I do this, I get everything. Remember, whenever you're trying to index an array, meaning whenever you're trying to access an array, the first index is always going to be the row index. And the second index is always going to be the column index. Now, you can see that here I've typed semicolon. Why did I do that? Let us try this out without the semicolon. If I don't have the semicolon, before I execute the code, I want to show that the size of the matrix is 3 cross 4. Now if I run this, you can see that now the matrix contains just one row and 12 columns. So it's very hard for me to distinguish where the boundary is, right? I know that this is the score by the first student and this is the scores by the second student and so on. So that's why having a semicolon helps, because when you add a semicolon, it creates a new row. Now here's the thing, right? Say that I just had one semicolon, and if I try to execute this, dimensions of matrices being concatenated are not consistent. Why is that? The problem is your first row only contains 4 columns, whereas your second row contains 8 columns. In other words, the problem can be fixed if I had 4 zeros here. If I run this, now you can see that it got fixed. Previously it did not work because these 4 elements were not present. So Matlab had a problem combining these 2 rows because each row is of different size. Okay, I hope that makes sense. So for now, I'm just going to delete this and we are going to add one more semicolon here. Run this. So now you can see that I have student marks. So now what I can do is I can basically create separate variables. I can basically say student 1 marks is equal to student marks of first row and all the columns, right? So let's run this. I get the marks for student number 1. Similarly, what I can do is I can type in student 2 marks. That's just going to be the second row and all the columns, right? I can copy this, paste it again, and this time I'm just going to change this to 3 and change this to 3 and execute this, right? So now if you see here, student 1 marks, student 2, student 3 marks, they are all arrays and they have size of 1 cross 4, right? So similarly, what you can do is instead of accessing one row or one column, you can extract a matrix as well. So for example, here the student marks is basically a 3 row and a 4 column matrix, right? What I can do is I can extract a matrix which basically has 2 rows and it has 2 columns, right? So 2 rows means I'll have the first 2 rows, and since I'm requesting only for the first 2 columns, I will just get this guy, this guy, this guy, and this guy. So let's check it out. So if I execute this, I'm just getting a small subset of my original matrix. Similarly, I can say that this is going to go from 2 to 4, or actually 2 to 3, and this is going to go from 1 to 2. So when I execute this now, I'll get 90, 56, 90, and 87, right? So similarly, what you can do is you can play with these indices. Now don't try to go over. For example, if I type in 3 to 4, right? Remember that you need to remember that the row index, the maximum number of rows is just 3, right? So if you try to execute this, it's going to basically say that the index exceeds the matrix dimensions, right? So what does Matlab mean by index? It represents these numbers, and it's basically saying that the number here, when it goes to 4, right, it actually exceeds the matrix dimension because the matrix contains only 3 rows, right? So this is a very common mistake that I see people do. So make sure that you are aware of this mistake. Now one thing that you can do is, if you're not sure how big your matrix is, you can type in 2 to end. So that way, doesn't matter what your matrix size is, it will start from the second row all the way to the last row. And you can basically play with this by typing in end -1. So if you type this, you are just going to get only 1 row because it starts from the second row and it goes up to the end keyword, which is 3, but 3 minus 1 is 2. So in other words, this is basically saying that you start from 2 and end from 2, right? Which means you are sticking to a particular row and you're getting the first 2 columns from it. And that's why you get only 90 and 56. All right, hope that makes sense. The next thing that we are going to be talking about is array generators. So Matlab is very, very useful in generating arrays. So for example, if I type in a is equal to rand of 1, 10, it's going to generate 10 random numbers. Similarly, if I have to generate 3 rows and 10 columns, then it's going to do that as well. I can do this to get a 3 by 3 random matrix. What I can do is I can multiply all of these guys by 10 so that my random numbers are between 0 and 10. All right. Similarly, what I can do is I can basically start from a particular number. Say I can do 5 plus rand of 3, 3. So what this is going to do is it's going to make sure that the random number is between 5 and 6. So you can play with this rand keyword to generate numbers in the desired fashion that you want. One practical advantage of this is for plotting. So for example, when I plot something, right, say that I'm plotting a random number. Say that I'm plotting a set of 10 random numbers. So I'm going to type in rand of 1, 10, right? So what's going to happen is Octave or Matlab is going to first recognize this it's going to run that. That's going to generate 10 numbers, and it's going to plot those 10 numbers, right? So when I execute this, you can see that the y-axis goes from 0 to 1 and x-axis goes from 1 to 10, which is the number of elements in that array. If I type this to 50, you can see that the x-axis goes from 1 to 50. All right. Now what I can do is I can color this guy, right? I can color this by red. If I run this, now you can see that the plot is red in color. Now what I can do is, instead of typing in red, I can use a matrix, a row matrix, and type in 1 0 0. So what does this mean? Well, colors can be represented as a combination of red, green and blue, right? For example, if you have a LED screen, if you zoom into the pixel, you will see that each pixel contains 3 colors, a red, green and blue. By varying these 3 colors, you can produce any color you want. So what I can do is I can have a matrix called color, and I can type in 1 0 0, and here I can just use that as an input. And if I execute this, you can see that I'm getting a red colored matrix. I can change this guy to 0.5 to basically get a much more darker red. Now the nice thing about the rand command is I can actually use rand, because each color, right? For example, if I take red, the value needs to be between 0 and 1, which is exactly what rand does. Similarly, I'm using a random value for green and random value for blue, which means I'm going to get a completely random color each and every time I execute this, right? And to make this fun, what you can do is you can type in for I equal to 1 to 200, and what you can do is you can just plot this guy, and if you type in pos of 0.03 and hit execute, you will see that there are several colors coming up. Now this might be a bit too fast for you, so what you can do is just modify this to 0.3 seconds so that you can see the color change a bit more easily, right? So this is one of those areas where the rand keyword can actually help us a lot by generating random colors. Alright, so now let's close this and let's talk about other ways of generating arrays. So the random keyword is useful, but it creates random numbers, which is not always useful. Sometimes you want to create numbers in an orderly fashion. For example, say that you want to create a number from 1 to 100. Say that you want to create an array from 1 to 100, right? You can type you can open up the square brackets and type in 1 2 3 4 all the way up to 100. But the easiest thing to do is to just type in 1:100. If you do that, you can see that the value of A is now a 1 row and a 100 column matrix, and it has 100 double values, and these are the values. So similarly, you can put this in square brackets, and if you do that, nothing is going to change. The results are still the same. So similarly, what I can do is, instead of just generating numbers between 1 to 100, I can provide a small interval. So for example, let us say that I want my starting number to be 1, and I want the interval to be 0.1, and I want to be the last number to be 10. If I do this, you can see that I have 91 numbers. You can see that I'm starting from 1, 1.1, 1.2 all the way up to 10, right? And you can make this smaller so that you can kind of see what happens, right? Now this number can be anything you want. So you can type in 1 to 0.5 to 2. That means you will just get 1, 1.5 and 2. You can type in 1.6 as well. You can see that it prints 1, 1.6. The next number needs to be 2.2, which is outside the range, so it stops there. Similarly, if you type in 0.4, you will get 1, 1.4, 1.8. The next number is 2.2, but it's not going to print that. Alright, so here in this type of array generation, we are providing the interval. But what if I want to generate an array of a fixed length and I don't worry about the interval? Well, that's where a linspace command comes. So you can type in a equal to linspace. The starting value is 1, the ending value is 1.8, and you need 3 values. Boom, you can get there. If you need 30 values, you just type in 30 and the array would get generated automatically. Now, how would you calculate the interval? Well, it's very simple, right? Since the interval is fixed, you can take any consecutive numbers. You can take a of 3 and minus that from a of 2. You'll get the interval 0.0276. Similarly, what I can do is I can take the 19th number and subtract it from the 18th number. The results are not going to change. That's because linspace makes sure that the interval is constant. Now, what is the size of A? Well, A is 1 row and 30 columns. So if you type in A of 1 to 30, you're going to get the entire array. You can get the first 15 numbers by typing 1 to 15. Now, the interesting thing is you can use the interval operator here as well. So I can type in 1 colon 2 colon 15, meaning I'm starting from the first value. I need to go up to the 15th value, but I'm going to skip every other number. So if I hit this, you can see that I get 1, 2, 3, 4, 5, 6, 7, 8, only 8 values. Whereas if I don't do this, I get 15 values, right? So you can use the colon operator and linspace quite effectively to generate arrays as you desire. All right, with that, I would like to conclude this video, and I'll see you guys in the next video. Bye.